I listened to all 35 minutes of the creator of Claude Code on stage at Y Combinator. Here it is, relayed. Start with the line that jumps out. They deleted 80% of Claude Code's system prompt. Not trimmed. Not refactored. Deleted. And this was not a one-time spring cleaning. His words, every time a new model comes out, we delete a bunch of the system prompt. Every generation, another round. That is worth stopping on, because for 2 years, everyone has been doing the opposite, accumulating prompts as an asset, writing them into documentation, treating them as a moat. The person who built the most used coding agent in the world says they tear most of it down every generation. Let's put names to this first. The speaker is Boris Cherny, the creator of Claude Code. The host is Diana Hu of Y Combinator. The venue is YC's Startup School 2026. The date is the day after Opus 5 shipped. There's a layer here I want to place before anything else.
This is YC's stage, YC's host, and Anthropic's own person talking about Anthropic's own product. It is not a third-party evaluation. The content is usable, and it is the only first-hand source, but it needs to sit where it belongs.
I'm not using that to dismiss any of it. I'm just putting it where it goes. Everything after this, you can listen to with that in mind. So why delete? His reason is one sentence, because every model is very different. That sounds mild, but it overturns an assumption a lot of people hold, that a prompt teaches the model how to work, so more detail is better, more coverage is better. What he means is that a substantial part of any prompt is patching the previous generation of model. His words, a lot of the stuff in the system prompt was correcting for behaviors the model should have known, but didn't. He doesn't list which behaviors, so the example that follows is mine, not his. The old model wouldn't go read the file it needed to read, so you wrote a paragraph telling it to go read first. That sentence was correct at the time, and it worked. Then the new model arrives. In his words, now Opus 5 just does it. Your sentences are still there. They have gone from help to instruction, from scaffolding to a cage. He has a name for this. It's actually a term that already exists in the research.
Hobbling. What he says is, the model can do it, and the product gets in the way. That getting in the way is what they call hobbling. There's a companion term, product overhang. The idea is that today's models can already do a great many things, not a future model, today's, and we have not yet realized it.
I think those two words are worth keeping because they reverse the direction of the work. You thought the job was making the model more capable. He's saying the job should be stop obstructing it. Those are two completely different product instincts. The first is addition. The model can't, so I compensate. The second is subtraction. The model probably already can, so I withdraw and see how far it gets on its own. So once you've withdrawn, how do you rebuild? This is the most practical stretch of the whole talk, and the order matters. The host frames it well. Everyone in this room is going to try Opus 5. Everyone is going to hit delete on their system prompt. Then what? He says, the first step is you delete. The next step is you use it. Notice what isn't in between. There is no step called think carefully about what to keep. His explanation, don't guess what instruction the model needs, because you'll probably guess wrong. What you want to do is run it and watch where it fails. Then put sentences back only for failures that actually happened. And there's a qualifier of his, I have to carry over. He says only when you see it repeatedly stumble on the same thing, that's when you add it back. Don't do it too early. Every sentence you add, the model has to read every single time you use it. The method itself isn't novel. What's novel is applying it to something everyone assumed could only grow. There's one more, aimed squarely at people who aren't building agent products and just use Claude Code. I think it's the most directly actionable line in the talk. He says, every 6 months, delete your sleuds.md. Delete your skills. Delete your hooks. See what the model does, because it might surprise you. I want to add one thing here.
Delete first, then watch where it fails assumes you are able to see the failures. If you run your product and you don't actually know where it went wrong, deleting gets you something less controllable, not a better prompt.
He returns to this himself later. He says verification is the thing people most often do not get right. I'll come back to it. Now the chairs. This means something different depending on where you're sitting. First chair, people building products. For them, this is a method. Every new model, delete first, then rebuild from real failures. The cost is that it's a per-generation job, not a one-time one. Second chair, people accumulating prompts as an asset. That asset depreciates once per generation. Not to zero. Part of it goes from helpful to harmful, and you don't know which part. That's worse than useless, because it's still in effect. Third chair, people whose job this is. He is direct about this one.
He says that a year ago, one of the most popular job openings was prompt engineer. Then it shifted, and it became context engineer. His words, there are these kinds of waves of it. They come and go.
I'm not going to embroider that. He said it. I'm relaying it. But it's worth hearing carefully if this is your job, because the person saying it sits at the top of this chain. Fourth chair is the exception he drew himself. This chair matters, because it's the one place in the whole interview where he voluntarily pulls back. The host asks him, "You've said before that coding is solved, so now that everyone can write software, what separates the exceptional builders from the rest?" The premise of that question is coding is solved. And the first thing out of his mouth is a qualifier on himself.
He says, I would give one caveat. Coding is solved for the kind of coding that I do. It is not solved for everyone. Then he names two very deep systems code bases where Claude still struggles. Distributed systems where Claude still struggles.
I'm pulling this out on its own because this is precisely the part that reposting sands off. Coding is solved is a sentence that travels by itself. It has the clean outline a perfect conclusion is supposed to have. For the kind of coding that I do does not survive the trip. Both halves are his. Same talk, same minute, same person. When you hear the first half, remember there's a second half attached. Now the hardest number in the interview. Someone on the Bun team used a single prompt to rewrite Bun, a JavaScript runtime of more than 100,000 lines, from Zig into Rust. Bun is the runtime Claude Code itself runs on. It ran for 11 days. It's in production. The host asks how long that used to take. Months, years. He says, definitely over a year. The number sounds great, and it comes with 3 qualifiers, none of which I'm dropping.
1. It was not one shot. The host asked directly, and he said no, there was steering. 2. The agent count is his estimate. Asked how many agents it spawned, he said, I'm not sure. I would guess thousands, tens of thousands. 3. This is a case study on his own product, related by him.
All 3 qualifiers stand, and the case still holds, and it's still remarkable. I insist on the qualifiers not to weaken it. A case that survives its qualifiers is more persuasive than one that's been polished smooth. So what is the skill that's actually changing? His answer is, I think, the most useful sentence in the whole talk.
He says the skill nowadays is less about prompt engineering and more about this. How do you give Claude a task that seems a little bit too hard? And then, how do you make it possible for Claude to verify its own work along the way? He adds, the verification, I think, is probably the single most important thing that people do not get right.
Take those 2 halves apart. The first half, give it something a little too hard, runs against most people's instinct. Most people break a task down until it's small enough that they're confident and hand over that. He says aim higher. Because when you break it down that finely, you're back in the same trap. You're deciding the route for it, and it may have a better route. The second half, make it able to verify itself, is the real threshold. The 11-day rewrite worked not only because the model is strong. It worked because that task came with verification built in. Rewrite a runtime, and you still have the old test suite. Whether it passes is not a matter of opinion. Take a task with no way to verify. Same model, same 11 days, and what you may get is 11 days of garbage, and no way to know it's garbage. So, verification is the word from this interview I'd most want you to keep. More than the 80%. There's one more passage I want to handle deliberately, because it's the strongest claim in the talk. He says that stacking 3 things together, a well-aligned model, a prompt injection classifier they run on all traffic, and another classifier layer on top, means they can no longer demonstrate prompt injection. That's a heavy statement. So let me be clear about how to hold it.
This is a vendor's safety claim about its own product, made by the vendor's employee on the stage of the vendor's investor. We can no longer demonstrate it, and it does not exist, are not the same statement. The first is a result from their internal testing. The second would require outside verification. He also says this isn't new to Opus 5. Earlier generations were already improving, and this one reaches a new level.
I'm not judging whether the claim is right. I'm not able to. I'm drawing its boundary so you can decide how far to trust it. Time for historical bearings. What is this like? 3 answers come to mind, and they point at different endings, so I'll put all 3 out. First answer, like handwritten assembly being displaced by compilers. That one really did go to 0. Handwriting assembly was once an elite skill, then compiler optimization beat almost everyone, and the craft retreated into a very narrow corner. If that's the answer, prompt engineering becomes a specialty for a small group rather than a requirement for everyone. Second answer, like handwritten SQL being displaced by ORMs. That one looked like 0 and wasn't. ARMs erased most handwritten SQL, and then, wherever performance mattered, people went around the ARM and wrote it by hand again. In the intervening years, people who didn't know SQL shipped things that worked, and people who did know SQL put out the fires. That arrangement is still with us. If that's the answer, it isn't disappearance. It's stratification, unnecessary in most cases, worth more in the few. Third answer, and possibly the closest to what he describes, like a framework major version upgrade. Your customization layer gets rewritten every time. The work doesn't vanish, but it moves from accumulation to redoing. That one is the least comfortable, because it means there's no end state. It comes around every generation. I don't know which it is, and it probably isn't purely any one of them. But I don't want to hand you only the reassuring answer. Finally, my take and what I'm watching next. My take is one sentence. The real claim in this talk isn't prompts don't matter anymore. It's, you had better know which generation of model your prompt is patching. Deleting 80% worked because they knew what that 80% was compensating for, and knew the model had since filled those holes itself. Someone who doesn't know what their prompt is compensating for, deleting by imitation, will just fall over. 3 signals I'm watching. 1. After the next major model release, does anyone else publicly do the same thing, delete most of the prompt, and say what they deleted and why? Once is an anecdote. Twice is a method. 2. Watch verification. If he's right, the tools that become valuable next are the ones that help you judge whether an agent did the work correctly, not the ones that help you phrase things better. 3. Watch the exception he drew. Deep systems code, distributed systems, still hard, he says. When that line gets crossed, matters far more than the sentence coding is solved. Because whether a sentence carries a caveat is something you can check. When the caveat stops being needed, that's the thing that actually changed.